In this tutorial from Chapter 6, we're going to cover some of the things that we may not have gotten to already in the book. And so I'm just going to ask a few questions and then show you how to answer them. The first question that we have is I want to write an equation for a polynomial function with zeros of x equals 2 that has a multiplicity of 2, x equals negative 1, a multiplicity of 1, x equals 1 with a multiplicity of 2, and this time a y-intercept of 0, 5. In order to write the equation for the polynomial function, I'm going to start off with what I know about the zeros. So I'm going to write f of x equals, and since I have a 0 at 2, I know one of my factors is x minus 2. The multiplicity 2 means I have it twice, and so I'm going to write that as squared. X equals negative 1 means I also have a factor of x plus 1. And x equals 1 means I have a factor of x minus 1. Notice it's multiplicity 2, so I'll also make it be squared. If I wasn't given any information about my y-intercept, I would be through. I would just use this as a function whose leading coefficient was 1. But in this case, I'm not sure what the leading coefficient is, so I'm going to put down an a. How do I know what a is? Well, I'm going to use the fact that my y-intercept is 0, 5, and so my x value is 0, my f of x value is 5, and I'm going to plug that in. 5 is equal to a times 0 minus 2 squared times 0 plus 1 times 0 minus 1 squared. I just plugged in my values for the y-intercept. 5 is equal to a times 0 minus 2 is negative 2. Negative 2 squared is 4. 0 plus 1 is 1. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I get 5 is equal to a times 4. A must be equal to 5/4. Now that I know what a is, I can write my equation. F of x is equal to 5/4 x minus 2 squared, x plus 1, x minus 1 squared. Problem number 2 is almost the same thing, except now we need to find the zeros ourselves. I look at the graph on the left and then realize that I have a 0 at negative 2. It must have a multiplicity of 2. Why? Because it's bouncing, touching or bouncing. When you touch or you bounce, that means you have an even degree. It doesn't look like it's hugging. I'm going to take it as its smallest even degree that could be, which is 2. I also have a 0 at 2, and I also have a 0 at 5. And I also have a y-intercept. Notice that the number here is negative 10, so my y-intercept is 2, 4, 6, 8, 0, negative 8. Let's put all that together. F of x is equal to some number a times x plus 2 with a multiplicity of 2 times x minus 2 times x minus 5. Plugging in my y-intercept, 0, negative 8, I get negative 8 is equal to a times 0 plus 2 is 2, 2 squared is 4, 0 minus 2 is negative 2, 0 minus 5, negative 5. Negative 8 is equal to 40a. And a, therefore, must be equal to negative 8 over 40, which is negative 1/5. I can write this as f of x is equal to negative 1/5 times x plus 2 squared times x minus 2 times x minus 5. That was the one on the left. Looking at the equation on the right, I'm going to see if I can make this picture a little larger so I can see it a little better. Okay, I see I have a 0 at negative 1 with multiplicity 2. I have a 0 at positive 1, and I have a 0 at positive 3. I've got a dot down here telling me what the 0 might be, but since I really can't tell what it is any better than I can tell what the y-intercept is, I'm just going to use the y-intercept here also. If we find that I need to give you another point, I will do so later. But go ahead and write it out. F of x equals x plus 1 squared, don't forget your a, times x minus 1 times x minus 3. F of x is equal to, well, I don't need f of x. Let's see what a is equal to. This, by the way, is 20, 2, 4, 8, 12, 16, 20, and so this looks like the y-intercept is at 0, 6. Now that I'm hopefully got my act together, 6 is equal to a times 1 squared, which is 1, times 0 minus 1 is negative 1, 0 minus 3 is negative 3, so 6 is equal to 3a, a is equal to 2, and I can write this function as f of x equals 2 times x plus 1 squared times x minus 1 times x minus 3. Problem number 3. Without using a calculator, solve 3x squared minus 11x is equal to negative 6. This is a quadratic, so I'm going to put everything on the same side. 3x squared minus 11x plus 6 equals 0. I should be able to solve this by factoring. I need two numbers that multiply to give me AC. A is 3 and C is 6. AC is 18. And I need numbers that add to give me B, which is negative 11. Okay, two numbers that multiply to give me 18 and add to give me negative 11 would be negative 9 and negative 2. So I'm going to write this as 3x minus 9 times 3x minus 2. Look for the greatest common factor. I've got a common factor of 3 here. I can write this as x minus 3 times 3x minus 2. Well, that has to be equal to 0. If a product is equal to 0, one or the other factors has to be equal to 0. So either x minus 3 equals 0 or 3x minus 2 equals 0. If x minus 3 equals 0, x equals 3. If 3x minus 2 equals 0, x equals 2/3. X is equal to 3 or 2/3. If you were to plug that back into the equation, you would find that they actually gave you the correct answer. 4x times x plus 6 cubed times x plus 3 times 5 minus 3x equals 0. If a product is equal to 0, one of the factors has to be equal to 0. So either 4 equals 0 or x plus 6 cubed equals 0 or x plus 3 equals 0 or 5 minus 3x equals 0. Well, 4 can't be equal to 0. If x plus 6 cubed is equal to 0, x must be equal to negative 6. If x plus 3 is equal to 0, x must be equal to negative 3. And if 5 minus 3x equals 0, then 5 is equal to 3x, so x is equal to 5/3. Problem number 5. X squared minus 16. Hopefully I can recognize this as a difference of squares. I get x plus 4 times x minus 4. Then I've still got my x plus 5. I also need to factor x squared minus 3x minus 4. Well, I can factor that as x minus 4 times x plus 1. So once again, I've got x minus 4 times x plus 1. All that multiplied together has to be equal to 0. So x is equal to negative 4 or positive 4 or negative 5 or positive 4, but I've already got positive 4, or negative 1. Those are my zeros. I like to have it in numerical order, so I'm going to write it as -5, -4, -1, or 4. Number 6. This time notice that instead of having an equal sign, I have a greater than sign. So I'm going to use a number line analysis. Let me draw my line and first put the zeros on there. X minus 4 means I have a 0 at 4. X plus 1 means I have a 0 at -1. X plus 3 means I have a 0 at -3. I notice that my leading coefficient would be x times x times x, which is x cubed, which is positive. So any number bigger than 4 would be positive. If you're not sure about that, go ahead and try a number that's bigger than 4, like maybe 5. If I plug in a 5 for x, 5 minus 4 is 1. Well, that's a positive number. 5 plus 1 is 6. That's a positive number. 5 plus 3 is 8. That's a positive number. A positive times a positive times a positive is a positive. Okay. I also notice that all of these factors have multiplicity 1, so every time I were to get to a 0, I would pass through it. That would make my signs change. This will be a negative. This will be a positive. This will be a negative. Once again, if you're not sure of that, you can always pick a number. Let's check to see a number between -3 and -1. A good number between -3 and -1 would be -2. If I plugged in -2, -2 minus 4 is -6, which is negative. -2 plus 1 is -1, which is negative. -2 plus 3 is 1, which is positive. If I multiply a negative times a negative times a positive, I get a positive. So my number line certainly appears to be right. Now, how's that going to help me? Where's the interval where this graph would be greater than 0? And the answer is in interval notation from -3 to -1, and then it picks back up from 4 to infinity. All right, here we go again. This one says less than or equal to 0. I'm going to draw my number line. I'm going to put in my zeros. Don't forget that x gives me a 0 at 0. I also have a 0 at 2, and I also have a 0 at -3. If I were to check out the leading coefficient of this polynomial, it would be x times x squared times x, which is x to the 4th. X to the 4th has a coefficient of 1, positive 1. So as I go out to infinity, I know that I'm going to be positive. Once again, just to make sure I'm going to check, I'll try a number like 3. That would give me a positive times a positive times a positive. Sure enough, I'm positive. Now, notice that the 2 came from this factor x minus 2, where if I were to have a graph, it would have been a bounce. Because of that, I know that this interval and this interval will have the same sign. I get to the one that was 0, it has degree 1. The signs are going to change. And when I get to the -3, its degree is 1. The signs are going to change again. Where is this less than or equal to 0? It's equal to 0 here. It's equal to 0 here. It's equal to 0 here. And all the points between -3 and 0 are less than 0. So my answer in interval notation is all the points from -3 to 0. Notice I'm putting square brackets because -3 and 0 are part of my solution. And then don't forget the point 2. All right, here's another one. I'm going to draw, this is strictly less than 0. I'm going to draw my number line to put a number line analysis. I will have a 0 at -2. I will have a 0 at +3. And don't get confused on this one. What number do I have to put in for x to make 4 minus x equal to 0? 4 must be equal to x. A lot of people want to put -4. My 0 is actually at +4. I'm going to look at my leading coefficient. My leading coefficient is going to be 5 times x squared times -x. Notice that I end up with a -5x to the 4th as a leading coefficient, as a leading term. my leading coefficient is negative 5. So as x approaches infinity, f of x must approach negative infinity. Like always, let me just check a number to make sure. I don't want to make a mistake and ruin everything from here on out. So pick a number bigger than 4, like 5. Well, let's see, that's positive. This will be positive. This will be positive. 4 minus 5 is negative. Sure enough, I get a negative out here. My 0 at 4 came from this factor. It has a multiplicity of 1, so I'm going to change signs. My 0 at 3 came from this factor. It has a multiplicity of 2, so I'm going to keep the same sign. And my 0 here at negative 2 came from this factor. It has multiplicity 1. I'm going to change signs. Where is this graph less than equal to 0? Or sorry, less than 0? From negative infinity to negative 2, picks back up from 4 to infinity. Now it asks me to use a graphing calculator to find the real solutions. Okay? So here we go. I'm going to try to show you the real solutions, and then I want you to put on a sketch so we can see that you actually did know how to graph this. So I bring out my graphing calculator. I'm going to go to y equals, and let's clear out whatever was there, and I'm going to plug in negative 2x cubed to the third power minus 3x squared plus 23x plus 12. I graph it. The x values look pretty good, but I'm sure I'm missing my relative max and my relative min. So I need to add and subtract from my y values. Let's go ahead and change the window. I'm just going to try to start with negative 50. And 50, if it doesn't work, it's not going to be a big deal. I'll just change my window again. But that actually looks pretty good. Okay, where are my zeros? Well, apparently I have 3 zeros. I'm going to look for the far left 0 first by going to second trace, which is calculate. Number 2 is the 0. It says left bound. I'm going to go to the left of that left 0 and hit enter. Then it says right bound. I'm going to hit enter. Giving it a guess. Oh, look, this 0 is at negative 4. I'm going to make my scale be 1, 2, 3, 4 on my graph. And so I have a 0 at negative 4. Let's find the second 0. Go second calculate. Now I'm actually already to the right of that second 0, which looks like a very small negative number. I'm going to hit enter, and then I need to, well, let's try that again. I don't know what happened. Okay, so I'm going to calculate the 0. I'm going to hit enter. Then I'm going to go to the right of the 0, hit enter. And it tells me, oh, this is negative 1/2. So I also have a graph at negative 1/2. I'm at negative 4, negative 1/2. And let's find this last 0 over here that looks like it's at 3. Just to make sure, let's calculate it. Second, calculate the 0. Oh. Back down. I could have just pressed enter to start with, but I like getting close just to make sure. And enter, and my guess, and sure enough, x is equal to 3. Okay. I'm going to look at the graph one more time just to make sure I do it correctly. It looks like it starts down, comes back up through, and then goes back down again. And so my graph will look something like this. Clearly, you just saw it, right? Where are my zeros? My zeros are at negative 4, negative 1/2, positive 3. All right, here's another one. This time, notice that I'm not equal to 0. Now I'm equal to 22x minus 63. How am I going to work that out? Well, this time, instead of having just one equation in y equals, I'm going to have 2. I'll clear out the first one. In y1 of x, I'm going to put what's on the left-hand side. Negative 21x to the 4th minus 22x to the 3rd cubed plus 42x to the 2nd, 42x squared. That's on the left-hand side. I put it in y1. In y2 of x, I'm going to put 22x minus 63. Now I'm going to graph both of these at the same time. I'm looking for an intersection. It looks like the intersection is happening way below the y-axis. So I'm going to make the y values be smaller on my window. I'm going to change my window. I'll leave the x values the same for right now. My y min, I'm going to change down to like -200 and see if that helps me find my intersection. Sure enough, I've got two intersections. Where the line intersects that quartic, that's where I'm going to find my intersection. So I'm going to go to second, calculate. Number 5 is the intersection. First curve and second curve, since I only have two curves, I don't spend much time worrying about those. That's fine. The guess, because it's an 83, I just get over here and get as close to the intersection as I can. Looks to me like the intersection is going to be where the x value is -2 1/3. The second intersection over on the right-hand side, I'm going to go second, calculate, and I'm going to calculate the intersection. Okay, first curve and second curve I don't worry about at all. On the right-hand side, I'm going to guess as close as I can. And the intersection here is 1.28. Sorry for the interruption. Apparently it's time for me to go have bagels and coffee. But my two values for where these are equal are -2 1/3, 1.28. I'm not going to draw the graph. Clearly you could have taken the graph and sketched it in there for me. Some sort of quartic here and some sort of linear function over there. Said I wasn't going to draw it and drew it anyway, didn't I? One more. Let's use a graphing calculator to find the real solutions for this. I don't know that I really needed to use a graphing calculator, but I will anyway. Okay, so let's bring the calculator back up. Go to my y equals. I'm going to clear both of these out. Now I'm going to put x squared times x plus 3 times. I always like to put a times between my parentheses. It makes me feel better since I used to have a lot of trouble when I was using 89s. They didn't seem to want to work out right if I didn't use the times sign in between. So I've got x squared times x plus 3 times 2x minus 1. I'm going to graph that one. Oh, this time it looks a little bit different. I need to close my window up. All my useful information is up near the top of the graph. So I'm going to also, it looks to me like I've got more x values than I need. So I'm going to change my x values -6 to 6. And I'm going to change my y values from, I'm only looking for where it's equal to 0, so I'm going to go ahead and change it from -5 to 5. I may decide I want to change that. Let's see what happens after I graph. Yeah, I don't really like that very much. Did I even do the window correctly? No, I made my scale be -5. Let's try that again. -5 to 5. Let's try that again, see what happens. Well, I would like to see my relative min down at the bottom, so I may, actually no, I don't think I am. I'm just going to look for where this thing is equal to 0. It's pretty easy to see that my first 0 is at -3, but let me double check. Second, calculate the 0. It's going to take a while to get back. Almost, oops, went too far. Okay, I'm at the left of the 0, so I'm going to hit enter. Then I move to the right of the 0, and I hit enter. And it tells me, sure enough, I have a 0 at -3. And my other 0 is real tight around the origin, so I'm going to change my window again so I get a better view around the origin. I'm going to do -1 and 1. And -0.1 and 0.1 just to, oops, let's clear that, and 0.1 just to see what really happened right there where that 0 was. It sure looks like it's bending. So what's happening is it's coming down like this, it's making a bend, going down again, and then it's coming back up somewhere on the right-hand side. Let's find this last 0. So I'm going to second calculate another 0. I'm going to get to the left of the 0, hit enter. I'm going to go to the right of the 0, hit enter, and let's take my guess. This 0 is at 0.5, so I've actually gone a little bit too far here. Let's back this up. I'm going to bounce at 0 and go right back up at 0.5 and go through. That tells me that my zeros must, or where I'm greater than or equal to 0, must go from negative infinity to negative 3, including negative 3. Okay. And then from at the point 0, I actually bounce, and so I need to add for the point 0. And then everything from 0.5 onward, I'm greater than 0. Less than 0 would be from negative 3 to 0, then from 0 to, I'll put 0.5 there, looks like a negative 5, to 0.5. Okay, let's see, I have a few more problems, but as you know, I have to go eat bagels, and so what I'll do this on the second tape. I'll finish all these problems from there. Hopefully this has been helpful for you, and we'll see you soon.